this year, that
Nice.
means that even our youngest son, he's not at home anymore. He
Mm-hmm.
went to university studying. So we are like retired people now, my wife and I.
Well,
Three kids out of
congratulations.
house.
Very
That's
nice.
yeah, that's a little bit of a change.
Yeah, now you have to figure out who you are when you're not with your kids.
Uh, we were already used to it. It was only the youngest one who was at
Mm,
home,
yeah.
and he was quite quiet. But now the holiday period, at once the three of them were at home,
Oh my, yeah.
and then it's yeah, a lot of noise, a lot of good moments, but it changes the habits.
Yes. Yes, indeed.
So is beginning of September also the new school year over there?
Yes, it is. And in fact, so we've the school has been in session now for 2 weeks, and uh, and in fact, I am volunteering a uh, um, at a high school. It's a private school. Leadership Prep School is the name of it in Frisco, and um, so I'm volunteering to teach first year computer science.
Okay.
So so yeah, we've gone through the old peanut butter and jelly sandwich exercise. I don't
And
know why
and
we always do that exercise.
and high school over there, that's 15, 18?
That would be. Yeah, yeah, I think that's the right age. Yeah.
Okay. Yeah, because the different names and the different
Mm-hmm. Yeah,
age ages.
yeah. This
Okay.
this school takes it's a really small population, so it takes a little bit wider range. So it's actually like junior high through high school. So I
Hmm.
think there's some in my class who are as young as 13.
All right.
So
And you will also, by the end of the year, you will go to historical modeling.
oh, of course, yes. Yeah, yeah. It's really fun. Yeah. So this is the Teals program. It's created by Microsoft, and they put together a curriculum to help
Hmm.
high school teachers to teach computer science. Even if the teacher themselves doesn't have experience, but then in addition to that, reaching out to the community and inviting professionals to come in and be an assistant once, twice a week. So I'm going in on uh, Tuesday and Friday mornings, and
Okay.
yeah, helping out the teacher who knows nothing about programming, but he's hoping that by the end of this year um, he will have acquired the skill just like his students, and then he could teach it himself next year. So I'm hopeful.
Oh, that's actually a good system
Yeah.
because over here in France and in Belgium, teachers are having big difficulties teaching computer science,
Hmm.
um, but they don't ask professionals to help.
Yeah, yeah. It's the sort of thing that a student's going to get stuck. They can't
Mm.
figure something out, and if the teacher can't can't help them out because the teacher's stuck as well, um, then yeah, you lose an awful lot of time and opportunity.
Yeah. The only subject for which I've seen it done here is for languages,
Hmm.
especially the French, because yeah, English is not their strongest
Hmm.
language. So sometimes they invite English people living over here to help teaching English to the students.
Hmm.
Um, but I've never seen it for computer science.
Yeah.
Might be
So
a good idea.
might be. All
Okay.
right. Well, I did hear from Caden. He's doing fine. Just busy. So
Okay.
yeah, school year has started for him as well.
Yeah. Well, he might be back once everything settles
Yeah,
over there.
indeed.
Um.
All
So
right, let's build an agenda. What? Uh, duh, 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 duh.
where was it in the show you this here. So let's just the screen, and then which one is it? Yeah, it must be that one. So that's the GitHub. You can see it.
Yep.
So actually, I made just a small branch here. Update roadmap picture. Yeah, where I added that picture from last time, and I made a pull request for it. Just an hour ago, I made a pull request, and then the other one, I looked back to the SQLite. So then I realized that actually the load, the save and the load were done. Code was still very messy because I wanted to clean it up since very long. Haven't done it. So save and load are done, but query is not done. But so I uploaded it to my GitHub here. So this is public now. Yeah, it's from December 2001. Then we started with SQLite.
Yeah.
And so the last one was all that transaction support. That was from March. But I never uploaded this save and load functionality. So I've uploaded them here.
Okay, good.
It's still messy, but at least it's there. There were a few tests with it, and all the tests are passing.
Excellent.
But so there I should still implement query. And I remembered that it was going to be a very difficult one.
Yes, and in fact, I would say that we want to learn from what we're doing right now with feeds before implementing a query, because that query is based on the or the one that you would be taking the example from is based on the serial pipeline, and we want that to be based on feeds that are derived from specifications.
Okay.
Which I am just now learning what the structure should be. So, yep.
So that might be the answer to my second thinking. I wanted to do that, but I also wanted to play with the Create React app and the Jinaga server client that you split up in two. Because I didn't really look into that yet, and I want to play with it so that I know a little bit more about it.
Yes.
So perhaps it would be better to do that first, dig deeper into the specification language before going to the query implementation.
Yes, I think so. And in fact, so I did fix the cores issue. So I've got a new version of the Docker image updated. So now if you follow those instructions, you should be successful all the way through. So that I think is the best next step.
Because the replicator, Jinaga no. So now you have Jinaga JS, which is actually only the client.
Correct.
Is that correct?
Yes.
Then you have the replicator here.
Yeah, and that's the Docker image. The source code for it is Jinaga server.
Yeah, because this one is still pointing to version 3. Look here.
Interesting. Okay.
So the Docker image is apparently not updated.
Okay, wait a minute. Where's this? Oh. Okay. Let's see what's let me make a note of that. Okay. Yeah, I made a note of that, but I'm not sure why. I'm not sure why that is. That is kind of strange.
Unless the internet is split in two now, and I see my local history and you see your
Yeah,
that
you
you
are looking
updated.
at the
But
Janaga organization. Yeah.
yeah,
Okay.
Jinaga, and then Jinaga replicator.
Okay. Yeah, that should not have even compiled then. Interesting.
I don't know. I was just looking into it. I didn't try anything further. Okay, that's another Docker
Yeah, that's the Docker
image.
image.
And the starter kit, that is a website.
Right.
And then here below, there was the Jinaga server here.
Yeah. Yes, that's the source code for it.
And
And so that
so
one should definitely be pointing at Janaga 401. Let's hope.
this one, is it?
Yeah, 401. Yeah. Perfect.
But so that one, and then which Jinaga is that?
Yeah, so that is the client side library, and it exposes all of the types that Janaga server needs in order to continue it from there. So the client side library is also the core. It's got all of the all of the logic. So Janaga server actually uses the client side library for all of its core stuff.
Okay, so it's this Jinaga JS.
Yes, yeah, it's that
it's
one.
pointing to. Okay, yeah. Indeed, Jinaga. All right.
Yep, I figured once I named the npm package, you knew that you were in JavaScript world, so I could just keep the name Janaga for the package, and then in .NET, the Janaga.NET NuGet package will just be called Janaga.
And you don't want to have a Jinaga core package and then a Jinaga server and a Jinaga client?
Yeah, I thought about that, but then as I was looking through the code that they had in common, most of the client-side code is the core code. There's very little that is strictly for use on the client side. Okay. Yeah, the things that are more client-specific ended up in Janaga React. And then there will be a different way of handling the client in Janaga Angular and in Janaga Vue. Yeah. So yeah, I guess in a way, Janaga itself is really the core. It's just it's a dependency, or as dependency free as it can be, and the dependencies that it takes can run in several different environments. So those dependencies can actually run in React Native. So that is one of the clients that I'll be targeting at some point soon.
Okay. All right. This is more or less clear. Good. Then I will play a little bit with it by next week.
Excellent. Yeah, I'd be excited to see what how far you can take that with the instructions as they are. What corrections or improvements that you suggest for the instructions.
Could just update that Jinaga replicator to 4.0.
Yeah.
That would be.
Yeah, I'm wondering if maybe that dependency ends up not being important because it uses Janaga server, and I think npm keeps separate dependencies. It keeps the dependencies of Janaga server in a subtree, and so that one will have 401, and so this dependency is probably just a leftover that doesn't actually need to be there anymore.
Okay.
And so it's pulling in 331 and not using it. So that's probably what's happening.
It should work then now.
Yeah. Yeah. So trying to think how far did I take the test? Because I'm in the habit of just testing live on the stream, but and apparently fixing things live on the stream too. But yeah, that should work.
So that's version 1 of the server.
Yeah. I decided not to start them at the same version number because they're going to diverge anyway. Yeah, so that depends on 401.
Yeah, okay. I will try it out, the replicator, and probably it will work. If not, I will shout and...
Excellent. Excellent. I will listen for the shouting. Okay. So, what I would like to share is an update to feeds. So, here is the... Oops, not that one. That one. Okay. Yeah. So, what I've started doing is taking the code that's in Janaga server now. After I've done the split, it was really easy to see where the different dependencies were. And in Janaga server, it starts with a parsed specification. The actual specification parser stayed in Janaga core, and so Janaga server turned that into a data structure, which it could then turn into SQL. And so along the way, it had lots of different assumptions built into that data structure that it knew that it was going to SQL. So part of the work was already done. So what I needed was a data structure that didn't know it was going to SQL, but still represented the query. And so that is the feed data structure. So a feed has facts, inputs, edges, and outputs. I think it's going to have more by the time I'm finished with it, but this is enough to pass the tests so far. So a fact is the type and an index, so that I can refer to that fact by its index in edges. And so the label that appeared in the specification has been erased, because this feed structure should really just represent the shape. It shouldn't represent any decision that the developer made that's kind of arbitrary, like naming the inputs and the unknowns. So it's got the type, because that's part of the shape of the actual facts. And then when you get to the edge, it's got the name of the role. So that's also part of the type information. So that's part of the shape of the subgraph that you're pulling out here. Mm-hmm. So you're saying, okay, let's identify all these different facts within the graph, and then here are their indexes. So labels have been replaced with just numbers. And then an input is that particular fact. It's actually this very specific instance. So here's the hash. And so that way a feed can start at a specific fact and give you all of the related facts starting from there. And you've got an array of those input descriptions, so you can start from multiple facts. You can have multiple givens. And then the edges have an index. Even though the index is not referred to within this structure, it ends up being useful in generating the SQL. So you can, when I generate the SQL, I alias the tables as F fact index, so F1, F2, F3, and the edges as E edge index. So I wanted to have that in this feed description as well. And furthermore, the order in which you place the edges is important. So yeah, this is an array. So arrays preserve order, but I wanted to be even stronger about that, and I'll say why in a minute. So an edge joins a predecessor to a successor, and so we've got the two fact indexes that refer back to one of those fact descriptions. And then the output description just simply says that fact, output it. And the output of a feed is going to be a stream of facts. So you can just index into that stream at any point, and then get the next batch of facts. So that's what a feed looks like. And so now when we take this specification and we run it through the specification parser and then give that parsed specification to the feed builder, it comes out with these feeds. So here's a specification saying starting at root, give me all child facts such that child root is equal to root. So just a simple successor join. And so that identifies two facts within the tuple. It's the root that you're starting with as fact index 1, and the child as fact index 2. So the name, root, and child, those have been erased, but the type, root, and child, those are preserved. And then the input is fact 1, and its hash is root hash. So down here, to help out with tests, dehydrating just a simple fact called root and a simple fact called user. So I've got their hashes. Okay, so that's the input, and now I have one edge, and the edge joins predecessor 1 to successor 2. So it's an arrow up from 2, up from the child, with the name root pointing at 1, the root. Mm-hmm. And then we output just fact 2, just the child. Yeah. And so this basically takes the algorithm that I was going through in order to generate the structure for SQL, and it kind of splits it in half so that you've got the part that understands the specification and how things are joined, separate from the part that actually produces the SQL. So the next step would be that you could take this data structure and actually just generate the SQL. And you don't need the original specification to do that anymore. It's preserved all the information that you need just to generate the SQL. And so that's going to be important. I should have started with why am I doing it this way? Because when you call the feeds endpoint and you give it a specification, it's going to give you back an array of URLs that you can then start pulling from each one of those feeds, very similar to an RSS feed. But the way that it's going to produce those URLs is it's going to generate this data structure and store this in a hash map, which is content addressed. So it's going to take the hash of this data structure, and that hash is going to be the address within the hash map, and that hash is going to be in the path of that URL. So now you can just perform a get against that URL, and the server already knows what the structure looks like, what query it should be performing. And the idea of erasing all of the labels, that means that over time you can evolve your application, and you can do refactorings, like just rename labels, and that should be just fine. You can also perform changes like adding new unknowns and conditions to your specification, which would generate more feeds, and the earlier feeds should actually have exactly the same shape as the ones that the previous version had generated. And so as you version your application, you get to reuse the bookmarks that you've already been keeping track of. So that's why I'm going through this extra step of generating a feed structure that doesn't know that it's going to be using SQL. And now this is a canonical standard for a feed. So that was a simple one. We've got a little bit more complicated one. So this one has two inputs. It's taking the user and the root, and then it's finding all of the assignments that point to that user, as well as point to a project that points to that root. So you've got a graph with two inputs. The thing that you're looking for here is the assignment. It's got an arrow going straight up to one of the inputs, and then another arrow that goes into immediate fact that goes into the other input. So it's a little bitty V-shape. And so from this, you end up with four facts. So you've got the user and you've got the root. Those are the two inputs. And then you've got the assignment that you're looking for and the intermediate project that it's going through. And so it finds these facts in this particular order because of the way that it traverses this data structure. So it's looking at this first condition. That's the very first thing that it actually produces output for, and it says, okay, on the right-hand side, you are accessing the user, and the user is an input. So therefore, you care about that user. I will add that as a fact. Then on the left-hand side, you're looking for the assignment. Okay, let's add the assignment. And then there's an edge directly from 2 to 1, so that becomes the first edge from 2 to 1, role name user. And then it moves on to the next one, and it says, okay, on the right-hand side, you're looking at the root. Okay, so root is added to the list of facts. And then the assignment is already there, so we don't need to add that again. It's the exact same assignment that we were talking about before. And then to get there, we go through the project, and so that becomes fact index 4, and we add that edge from 4 to 3. So from the project to the root with the name root, and then from the from the assignment to the project with the name project. So it has to output those in the reverse order of how they appear on the left-hand side. And that's because we are, by the time we get to actually generating the query, we're starting from the root. That's the input that we already know about. And then we have to do the join to get to the project first. And then we can do the join to get the assignment. So it has a little bit of knowledge in the way that it walks the graph. Oh my goodness, where are those coming from?
It's not me.
My cat is leaning back on something, but he's leaning on my. There we go. Yeah, leaning on my my clicker. So pushing the black and white, or the blank button.
And now the B from back.
All right. Silly, silly dumpling. All right. Okay. So yeah, it knows a little bit about how this is going to be used, and that's partly because this algorithm is derived from the algorithm that I created for the SQL. I did it that way so that I knew that you could, with this structure, generate SQL and it would be successful. So so it's an intermediate step that that does a bit of that processing for you, so that then when you generate SQL, all you have to do is walk through the edges in this order. So that's why I wanted to make sure that I'm preserving that order and produce those joins.
Okay, and so if we implement query in .NET, we'll have to go through this syntax.
Yes. Yes, indeed. Yep. So yeah, in this one, it just outputs fact index 2, so it just outputs the assignment. The inputs are 1 and 3, because those are the orders in which it discovered those inputs within the conditions. So if you've got an input that does not show up inside of your conditions, then it's never added to this facts collection. And that's important because this is output partway through as we are as we're evaluating this specification. So if we go down to the next example, we can see why that's the case. So in this example, we've got an existential query, and so we've said, okay, we've got the user joined to the assignment, and then the root joined to the project, joined to the same assignment. But now we want to have this existential condition. So this has to produce two feeds. We produce the feeds of the assignments for which this condition is true, the assignments for which we do not have a revocation, and we produce a feed for the revocations. Mm-hmm. Because if you never learn about the revocation, then you're not going to know to remove the assignment from your projection. So so that's why we end up with a feed array from a single specification. And so the first feed that it outputs is just the same feed that we saw before. So yeah, from the fact from the user and the root, join to the assignment in two different ways, and then output the assignment. So this one, yeah, this is where the data structure is going to get a little bit more complicated, because right now this data structure does not capture the existential condition, but it needs to have enough information to generate that where not exists clause. So I'm going to add that to the feed data structure as I make this test pass. This test is not passing, you can see down here. And then the second feed is actually the feed of the revocations. So it's the same inputs and the same edges down until we get to fact index 5, the revocation, looking at the assignment 2. So here's an edge from 5 to 2 with the role name assignment. So this is going to just do all those joins and get us to the assignments for this user in that root, that and it will give us the revocations for those assignments. And so the outputs are the assignment and the revocation. And so it has to produce all of the steps along the way. As it so happens, in this particular case, if you get the revocation, you will also get the assignment because it is a predecessor. But in general, that's not always going to be the case. So it just outputs all of the facts along the way. So if it were preserving the labels, that would be the labels that are defined along the way to it, but it erases those and replaces them with numbers. So yeah, this one, it should, we should add that existential condition here. And so let's suppose that you were working on this application, and at first you wrote this specification. Maybe you write it in Link, and then Janaga.net converts it into this specification. And so you're looking for assignment or facts of type assignments where assignment user equal user, where assignment project dot root equal root, and you say, okay, let's ship that application. So it's going to send that specification to the server, and the server is going to respond with 2 feeds, and that's going to be hashes of these 2 data structures. Oh wait, no, I'm sorry. In this one, it's 1 feed. So it responds with 1 feed. That's a hash of this data structure, and you start consuming that, and you get all of your assignments. And then you ship the feature of being able to revoke an assignment. It's like, oh, I missed that. We should be able to unassign people. And so then you update your source code, which now produces this specification, and go ahead and ship that. And so that is going to cause the server to produce 2 feeds. One of them is going to be very similar to the original feed that you had, but it will have this extra existential condition. And so that's going to cause it to create a new hash, and so that's going to be a different feed. If you start to follow that feed, then it will skip over the assignments that have been revoked. So in that case, your application is going to see a brand new feed URL, say, hey, I don't have a bookmark for this one, and it's going to start walking. And every fact that it gets back, because it's getting back all of the assignments that have not been revoked, those are assignments that it already knows about. It's just skipping over the revoked ones. And so it's going to pull a bunch of hashes, take a look in its database, say, yeah, I've already got them, and then just go back and keep walking that bookmark. It's not going to call load. And then it'll see the other feed, which is the feed of the revocations. And so that will actually cause it to now actually get the revocations. And now that this version of the application knows about revocations and what to do with them, then it will update the projection by removing them from the view.
Yep.
So this supports versioning, and in that case, it's not reusing the bookmarks that it already had. But let's suppose that you then, after this, had a projection that said, okay, for each assignment, now I'm going to look for the assignment name, or the date, or whatever, some successor of the assignment. And so that will produce a third feed within that list, and the first 2 feeds would be unaffected. They would be exactly the same structure. So if version 3 added that feature, then it would be able to reuse the bookmarks that version 2 had already set up. And so you ship that, somebody upgrades, and they don't have to sit there and wait for the application to walk through all those bookmarks and recognize that it doesn't have any new information. It'll just say, oh, I've already got this bookmark, it's at this point, let's just continue forward from there. And then it'll see a new feed. Oh, I don't have a bookmark for this one. Let's go ahead and walk that one, and it will get the brand new information, the assignment name or priority or whatever. So that is the reason for these feed objects, and they're starting to come together. Right now, the test fails because I don't have the second feed yet. So I'm just pulling in bit by bit code from Janaga-server into Janaga core, and then erasing all the bits that know that it's targeting SQL. So what it was doing before is it was jumping. It was loading the fact type IDs and the role IDs from the database, and then putting those into the data structure, so that they could then become parameters. So it had an array of parameters. It said these are the parameters and these are their values, and so it knew that it was looking at data from that particular SQL database. But you go to a different database, and the fact type ID and the role ID is going to be different. So this one preserves the fact type names and the role names, and then the lookup of these names and turning them into IDs, that would be done after this step, not before. So just rearranging things a bit. So by the time you get to working on the SQLite query endpoint,
yeah, that will be.
It's going to be taking this data structure.
Yeah. Okay.
Yeah, and what I haven't actually looked over this yet to confirm, but my suspicion is that this specification type is similar enough to Janaga.net. Let me see. Yeah. Uh-oh. Okay. Ah. All right.
Let's throw you out.
Yeah. Let's open it in VS Code for right now. Yeah, I just can't get to the right browser to log in again. Okay, so in our little terminal over here, I'm going to go to Janaga. Oh, yeah, it's not WSL. Janaga.net. All right. Let's take a look at that one. Okay. Oh, yeah, I actually am in the habit of opening it in VS Code, because we do all of the notebook stuff. Okay. But in here, we have yeah, just the core Janaga, and this has a somewhere in here is a specification. Okay, yeah, it's just right here at the root of Janaga, and so this is a data type that that it goes from a query, an iQueryable, into this specification. So the query provider produces this specification. And so here we've got a pipeline and a projection. And in this one, we've got our given, our matches, and our child projections. So I think we'll find that given and matches kind of align with pipeline. So we've got starts. Okay. Yeah, those are the givens. And then the matches, we've got path and conditionals. Whereas a match is a label and a condition. Okay, so yeah, the structures are a little bit different. Yeah, so we start from a different label and from some label, and this is strictly an existential condition, is what this one is. Whereas path is a going from one label to another, start to target, along different steps, and each step is a role and a type, and you've got how does it know if this is a predecessor step or a successor step? Okay. Oh, okay. Yeah, we've got the array of predecessor steps, the array of successor steps. Okay. Whereas this one, a condition is either a path condition or an existential condition. So the conditions have been moved down into this part of the data structure, and so you've got roles on the left of the path condition. So there's the left side and the right side of the equal sign, and then roles on the right. And the constraint is that the left side starts with the unknown, so the right side starts with something else further up. So all of the roles on the right-hand side are successor steps, and then all the roles on the left-hand side are predecessor steps. So yeah, there is some work in order to convert from this data structure to this data structure. What I think I would like to do is refactor the query provider so that the specification that it produces is closer to this one. Because I've learned a lot working on this update to Jnaga.js, and this is the way that I want specifications to look. So once this looks like this, then we should be able to translate the code a bit more directly, so that the Jnaga.net client would be able to parse that specification and then just purely on the client side turn that into a set of feeds that then it gives to the SQLite provider that turns those into SQLite queries. Yep.
It's a nice development.
Yep. Yeah, I hadn't looked at that data structure in a while. It's yeah, there are some problems with that. But we'll get that fixed. Okay. So that's where we are now with the feeds, and yeah, the replicator image should work for you. So by this time next week, I think I should have the feeds endpoint working in Jnaga.js. Maybe even the feed endpoint as well. So pulling each individual feed and running the SQL.
Okay.
Yeah.
that would be a nice development. Because next weekend and the week after there will be your approvals.
Correct. Yes.
And I'm out also. All right. Good.
Very good. So, yeah, I believe that is all we needed to cover today.
Yeah, I don't have further questions anymore, so I think you can go earlier to work today.
Fantastic. Yep. And yeah, I just want to double check the agenda here. So yeah, we covered the feeds updates. Yeah, so I've got a note here to update the Janaga replicator to use Janaga 4, to pull in. Well, that's still part of the. It's still part of the branch that's the pull. I'm looking at the save and load functionality. So you committed that. So yeah, it's not time to merge that in yet, but I'll review that and see everything working there, and then you've got the pull request for documentation. Yep. So I'll make sure that that gets pulled in.
The load in the save is not cleaned up yet, so I just put it there public. Mm-hmm. But whether it's time to pull it in, that's another question.
Okay.
Perhaps I can, if I have time to clean it up this week. But I want to first make some testing with the replicator image. Mm-hmm. Okay.
Very good.
Michael, thank you very much.
Thank you, Jan.
And see you next week then.
Yep. See you next week.
Okay. Bye-bye.
Bye.